Assalamu alaikum everyone. So today we are starting our session 8. So in this session we will discuss about how to configure the VLAN in big IP and how to associate a VLAN with the self IP addresses. What is the purpose of NAT and what are the functions? And we will discuss about different type of nets like static netting, source netting and dynamic netting, which is a very important part in application delivery controller. And also we will discuss about application delivery controller objects like node, pool member and virtual server. And at the end of the discussion I will show you how to create a virtual server, pool member and a node. So let's discuss how to create a VLAN, and also I will show you with my own lab how to create a VLAN. So let's discuss first, then we'll do a lab. When you would like to create a VLAN, first you need to assign a name, a tag number, and you need to decide either you would like to tag or untag the traffic. Tagging and untagging is totally depends on your network environment. I'll show you with my next slide that on which scenario you need to tag and which scenario you need to untag. So once you create a VLAN, you need to associate with the self IP. Self IP is an IP address which is used for communication with the server. So self IP can be external self IP or it can be an internal self IP. So we will discuss in our coming lectures in detail about self IP. There are two types of self IP. One is on self IP and the other is floating self IP. So we'll discuss in detail. So you don't need to worry about this. So once you create a VLAN, you need to associate that particular VLAN with a self IP address. Otherwise, there will be no use for that particular VLAN. So how you would decide that whether you need to tag or untag the VLAN? So let's suppose if you have multiple servers on a different VLAN and you have a single link that is going to your core switch. So you need to tag that particular all traffic. You need to tag all the VLANs on the FI on the big IP. Similarly, if you would like to make a separate link on F5 for each different VLAN, then you need to create a separate link with untagged traffic. So I hope it understands how to decide a tag or untag. So let me show you how to create a VLAN and how to associate that VLAN with a self IP address. So first you need to access a device. Once you access a device, you need to go to network, click on VLAN. Once you click on VLAN, you can see there's a create button. Click on create and you can name it server VLAN tag 4092 and you need to select the interface and either you would like to tag or untag. Let's suppose I select it untag, then click add and that's finish. So once you finish, you have to wait for the device to push the configuration. The configuration, you can see that the VLAN is created with the name server VLAN and the VLAN tag is 4092 and it is associated with port 1.3. So once you create a VLAN, you need to associate that VLAN with a self IP address. So now you can create a self IP 10.128.15.1 server VLAN self IP. So let's suppose I'm giving 10.128.3.2. The net marks 255.255.255.0. So now you need to select your VLAN, which is the VLAN port lockdown. All it is for the management purpose. Which VLAN which port number you would like to allow and which port you would like to deny. We will discuss in detail once we reach on this topic. So once you select a VLAN and the IP address, you need to click on finish. So you have to wait for the configuration. The requested name object is invalid. So let's try again. So now it is created because we have given. Why it gives an error? Because we have given the space, so it didn't accept that space. So I hope it understand how. So now you are able to understand how to create a VLAN and how to associate that VLAN to the self IP address. So let's discuss about static netting. What is static netting? Static netting is one-to-one mapping between two addresses. And the one very important thing is that the static netting is bidirectional. What does it mean? It means that the destination address will translate in one direction and the source address will translate in the other direction. So the other thing, in which practical scenarios we need to perform a static net. Like let's suppose if you have an email server in which it is necessary that incoming and outgoing traffic both will go within same IP address, right? So you have to perform the static netting. Let's discuss the static netting with an example. You can see that this server is statically netted on this IP address. So let's check how it is done. From internet, the client is requesting for a HTTP traffic to access this web server on port number 80. So for the client, the destination IP is an outside IP of the router. So once the packet will arrive here, the destination will be netted to the actual destination. So as I told you that destination address translation in one direction. So in this direction, destination will be netted. Similarly, if the server will give a return response, what will happen? The source IP of the server will be netted to a router external interface. So again, as I mentioned that source address translation will happen in other direction. So when the traffic will come inbound, destination address netted, and if the traffic is going outside, the source address will be netted to the router external interface and then it will go to the client. Let's suppose if the source is not netted here, then if the packet will arrive, the client will discard the packet because he has initiated a connection with that particular IP address. So this is a source netting. So let's discuss about destination net. So destination net is a very simple way to publish your web servers on a public cloud. So in this case, in this example, let's assume that this is an IP address of public IP that you have taken from the ISP and you would like to publish this server on internet. So what you have created, you have done a destination NAT on a router. So once any client will reach to the router, the destination will be translated to that IP address. So once the destination will be translated, it will reach to the web server. Now let's discuss about SourceNet. What is the use case of SourceNet in big IP clients? Everyone is aware of SourceNet because when a client is accessing the internet, he must be translated to a public IP address. So in a SourceNet, your private IP address is translated in a public IP address. So let's discuss in terms of big IP appliance why we need a SourceNet. So let's suppose this is your big IP and here you have a core switch in which your big IP appliance is connected. And let's suppose this is your a web server and this client needs to access that particular HTTP service on a web server. So the traffic will come here to the router and we have made a rule of destination NAT that it will route a traffic to a web F5. So the F5 will listen a traffic on a virtual server and it will forward the traffic to the web server. So once the traffic reach to the web server, the return traffic will go to the core switch and then it will go to the internet directly and the client will not able to see a response. Why? Because The server default gateway is a router, not a big IP appliance. So in this case, there will be a asymmetric routing issue. So to avoid a asymmetric routing issue, we will do a source NAT in a big IP appliance. So now let's discuss about application delivery controller objects. The big IP is by default is a denied device. What does it mean? It means that it will deny the traffic if there is no listener. So what is listener? We'll discuss. There are some objects that we need to define in big IP in order to process the device. So what are the objects like virtual server, node, pool member and pools? So let's discuss one by one. What is node? Node is a real server. What is node? A real server. It represents the real server. So when you will configure the big IP device, if we configure the real server, it is called as node. Similarly, what is a pool member? The actual application service is called a pool member. What does it mean? Like, we know that this is a node, right? Only the IP address of a real server is known as node. And if we assign a application port, it will become a pool member. So the actual application service is a combination of node plus port. So this is a pool member. And what is a pool? A logical object that contain one or more pool members. Like here, this is a HTTP pool. So in that pool, there are different members. Pool member 1, pool member 2 and pool member 3. So these are known as pool. And what is a virtual server? Virtual server is the listener. Like I have shown in this example that this client is trying to access this application using an F5. So there must be some certain objects that we have to configure it. The first one is a virtual server, which is a listener, and the syntax of a virtual server is IP address colon then port number. So this is an example that you can configure it with an IP address plus port number. So once you configure the virtual server, the big IP will able to listen the traffic, and this virtual server will be associated to a pool, and that pool will contain pool members, right? So this is how the big IP is working. So let's do a lab, a basic lab, how to create a virtual server, pool member and all these objects. In my lab environment, I have made this topology. Like I have a one big IP device, and this big IP device is connected with a virtual server, which virtual switch, because I have configured in a VMware environment, and I have configured three servers: server 1, server 2 and server 3, and the IP address of my servers are 172.1600.1, similarly 172.1600.2 and 172.1600.3. So these IPs will act as a node, right? And if we add a port, it will become pool member. So the first step in our lab, we will create a node. The second step in our lab, we will create a pool member. The third step in our lab, we will create a pool. And the last step in our lab will be virtual server. So let's do it. So I will access my big IP appliance. So first, as I mentioned to you, that the first step is to configure the pool member node. So we will go to the node and I will create server 1 172.16.100.1. Repeat. I will create server 2 172.16.100.2. repeat. I will create similarly server 3, which is 172.16.100.3, and then finish. So I have created these three servers. Now the next step is to create a pool. So I will name as test lab. Okay, and we can assign the health monitor, but we are just going on a basic mode. We are selecting a round robin function. We will discuss in detail in our next lecture. What is priority group, we will also discuss. So now node name, we have selected a node list because we already have a server, and now I will assign a port. So this will become my pool member. So simultaneously I am creating a pool plus pool member, and secondly I will assign port 80, and for server 3 I will assign port 80, and finish. So we have performed three steps. The first step, we have created nodes. In second step we have created a pool members plus pool, and last step we have to create virtual server. So as per my lab, the virtual server is 128.10.1.36. This is my external side. So I will create an IP address of 10.128.10.36. The port will be 80, and in last I will give a test lab, and that's it. So now let's check whether we are able to access the server or not with the public IP address. So still we are not able to access. So let me check. Let me enable the auto map, and we'll check again. So here we go. So this is, you have seen that this is server 3, this is server 1. So the response is coming from server 1 and server 3. So let me check why the response is not coming from server 2. Here the response is coming. Let me check my big IP. Server 2. Okay, see, I have given the wrong IP address. So that's why my response is not coming. So what I will do, I will create a new node, or I can delete this one. So if I delete this, it's saying that it's already in used. So first I have to remove it from the pool list. I will remove it. Once I remove, I will delete from here, and then I will create again with a correct IP address. So it is also good that you saw that how to troubleshoot if some server is not working. Finish. Now we will go to the pool again, and we will assign a pool member, server 2, from the existing list, which is this one. The port is 80, which is HTTP. Finish. Now let me check again. Once it is saved, now the response should come from server 1, 2 and 3. 2, 1, 3, 2, 1. So we have seen that how the big IPs works. Like the traffic is coming on the virtual server. So once the traffic listened by the big IP appliance, it forward the traffic on a servers by different load balancing methods, which is we will discuss in our next lecture. So I hope that you like my lecture, and we have also done the lab with some basic troubleshooting. Thanks a lot. So if you like my videos, kindly do subscribe my channel for more updates. Thank you. Take care. Allah Hafiz.